Hello, this is Teacher King David. We are going to study part 4, lesson number 2. So part 3, we saw multiplication of complex numbers. So now we're going to see conjugate of complex numbers. The conjugate of complex numbers. The conjugate of a complex number is noted as Z bar or Z star. That's how we note conjugate of a complex number. For example, we have a Z, which is A plus BI. The conjugate of this Z is A minus BI. So what does it mean? It means that the only part that changes always is imaginary part. It changes by sign. If it is positive, it has to change by negative. If it is negative, it becomes positive. For example, let's take Z equal to 1 plus 3i. Then the question is find Z conjugate. How are we going to find Z conjugate? Here to get Z conjugate, if Z is 1 plus 3i, I told you that Z conjugate, we have to change imaginary part. We change its sign. So now, if Z is 1 plus 3i, the answer is going to become 1 minus 3i. We just change only imaginary part. We change its sign. So this one was A. B, we have Z equal to 2. Then, what is its conjugate? How can we find the conjugate of that Z? I told you that the only imaginary part is the one to change. So do we have imaginary part here? Our imaginary part here is 0. So meaning that our Z conjugate, since Z is 2, our Z conjugate also is 2. Because here, imaginary part is 0. And 0, when you have 0 which is positive and 0 which is negative, it is 0. So the conjugate of this Z is 2. So we have Z equal to I. Then find its conjugate. So what is the conjugate of that Z? I have Z, which is I. And we have to change only imaginary part. Actually, this is the pure imaginary part. So the conjugate of Z, it is negative I. D, we have Z T equal to 3I plus 4. Find T conjugate. How can we find T conjugate? T conjugate, I told you that we have to change imaginary part. So what is our imaginary part? Our imaginary part is 3i. So we're going to change this 3i. It is positive, so it will become negative. So this 3i plus 4. So that's how we can write the conjugate of t, which is 3i plus 4. Its conjugate is negative 3 plus 4. Let us have E. Our E is saying that given that W equal to 2I minus 4, find the conjugate of W. That's the question. How am I going to answer that question? I have to know that the only part to change is imaginary part. So where do I have imaginary part? My imaginary part is 2. And which sign is it? It is positive. So it will become a negative. W is 2i minus 4. Its conjugate is minus 2i minus 4. So that is the answer. So let us try to see properties of conjugate. Properties of conjugate. So when you have Z plus W conjugate, it is the same as Z conjugate plus W conjugate. Z plus W conjugate is the same as Z conjugate plus W conjugate. For example, let us have Z equal to 2 plus 3i and W equal to 1 plus I. Then show that Z plus W conjugate is the same as Z conjugate plus W conjugate. Okay, so now, if our Z is 2 plus 3i and our W is 1 plus I, we're going to show that Z plus W conjugate is the same as Z conjugate plus W conjugate. So now, let's first get the value of left-hand side. I'm going to first try Z plus W. Our Z is 2 plus 3i, then plus 1 plus I. Then 2 plus 1, that's 3. 3 plus 1, that is 4i. That is Z plus W. So what is Z plus W conjugate? It is the conjugate of the answer. That is 3 plus 4i conjugate. So what is the answer of that? Because the imaginary part is positive, it will change, we'll get negative. That's 3 minus 4i. So therefore, Z plus W conjugate, its answer is 3 minus 4i. That's the answer for left-hand side. So let's just check for right-hand side. So for right-hand side, we're going to first find Z conjugate. Our Z conjugate, because Z is 2 plus 3i, our Z conjugate is 3, it is 2 minus 3i. And our W is 1 plus I, its conjugate will be 1 minus I. So now W conjugate, it is 1 minus I. So what is Z conjugate plus W conjugate? So it is the conjugate of Z plus the conjugate of W. So our conjugate of Z is 2 minus 3i plus the conjugate of W, which is 1 minus I. So now 2 plus 1, that is 3. Negative 3 minus I, that is negative 4i. You see now, left-hand side, so since left-hand side equal to the right-hand side, it is correct. We have proved that Z plus W conjugate is the same as Z conjugate plus W conjugate. Then, hence proved that ZW conjugate, Z plus W conjugate is the same as Z conjugate plus W conjugate. Hence proved that Z plus W conjugate is the same as Z conjugate plus W conjugate. So for property number 2, it is product. When you have Z times W conjugate is the same as Z conjugate times W conjugate. Let us take example. Let Z be 1 plus 3i and W 1 plus I. Then you're going to see if Z times W conjugate is the same as the conjugate of Z times the conjugate of W. Now, let's start with Z times W. It is 1 plus 3i into bracket 1 plus I. So now the answer is 1 times 1, that is 1. 1 times I, that is I. 3i times 1, that is 3i. 3i times I, that is 3i squared. So which is 1 plus I plus 3i, that is 4i. I squared is negative 1, that is negative 3. So which is negative 2 plus 4i. So this is our ZW. Then what about ZW conjugate? ZW conjugate is negative 2 plus 4i conjugate. Where, I told you that we change the imaginary part. We change its sign. And now its sign is positive. So it is going to become negative. That's negative 2 minus 4i. So that is ZW conjugate. So this is our left-hand side. We're going to try right-hand side, which is Z conjugate times W conjugate. So let us first try the conjugate of Z. Our Z is 1 plus 3i. Its conjugate is 1 minus 3i. So W is 1 plus I. Its conjugate is 1 minus I. So now the product of their conjugates. So we have Z conjugate times W conjugate, which is 1 minus 3i times 1 minus I. So now here, 1 times 1 is 1. 1 times negative I, that's negative I. Negative 3 times 1, that's negative 3i. Negative 3 times negative I, that is positive 3i squared. Then, that is 1. Negative I minus 3i, that's negative 4i. Here we have squared. I squared is negative 1, that's negative 3. So Z conjugate, W conjugate, the answer is 1 minus 3 is negative 4, I mean negative 2, then minus 4i. You see now, right-hand side is the same as left-hand side. Then since left-hand side is the same as right-hand side, then proved that ZW conjugate is the same as Z conjugate times W conjugate. So that's property number 2. Then property number 3. We have Z divided by W conjugate. This will be equal to Z conjugate divided by W conjugate. So we will prove this one after studying the division of a complex number. That's when we prove this one. So let us stop from here. Lesson number 2. We'll meet next time. God bless you.